Hello everyone, and welcome back. So now it's a group problem. So grab a friend, grab a sibling, grab your parents, grab your stuffed animal, whatever it is, and let's start working on this problem together. So what do we have here? Well, we have a 2-pound brick that slides down a smooth roof. Okay, no friction, with an initial velocity of 5 feet per second. What we want to know is the speed at B and the distance d from the wall to where the brick strikes the ground, as well as its speed at C. Okay. Can we solve this? Well, the answer is yes, and I'm thinking some kinematics are going to come into play. But I'm going to send you off as normal, with a plan, of course. I'm not going to leave you just by yourself. And you're going to go try this, and you tell me how it goes. So, your plan is as such. Apply that principle of work and energy to determine the speeds at B and C, and then apply the kinematic relations in the x and y directions to figure out the rest. So I think that's enough. I think you'll be able to figure it out from that. So with no further ado, I'll let you go. 3, 2, 1, and you're back. So hopefully it went well. Let's try this out together. First off, principle of work and energy. What kind of energy do I have here? Well, all I have is, yes, the weight acting on this block. So there's that weight acting on this block. Now it moves 15 feet down, and the weight is pulling it down. Now you're wondering, like, where's this 2? Where's the 9.81? This is pounds. This is the FPS system. And so because of that, FPS, first person shooter, sorry. This is the English system. And because of that, it already is a force. Now, one place you have to be very, very, very careful about is weight is not mass. Pounds is not equal to mass. The English unit of mass is the slug. And the way you get that is you take your pounds and you divide by 32.2. That will get you to slugs. And that is what you have to put into your 1/2 mass times velocity squared equations. If that confuses you, just take my word for it, okay? Take my word for it. It's the whole weight equals mass times gravity, and gravity in the English system is 32.2 feet per second squared, and the mass is slugs, which is not very often used, but it's there. Now, with this is enough to solve for the velocity at B. So we figured out, and we get that VB will be 31.48 feet per second. Interestingly enough, we can do the exact same thing, but now the full distance to figure out our total velocity at C. Because we don't have to worry about the direction, we're not worrying about the components, it just said how fast are you moving at point C. So this is what's amazing about the work and energy equation. I didn't have to do any crazy kinematics right here to figure out the velocity, break it into components, none of that. I was able to just go straight to the velocity at C, and I knew exactly the velocity at B. But the last thing I have to figure out is the distance. How far did it go? And that seems like it's going to be difficult. And until you realize that you know exactly the direction of VB because you know the slope of the roof. And if you know that, you know the x component of velocity. So I think we can figure this out. So first off, let's get an equation for its position, the time it takes it to get to point C. And what we're going to see is that it's traveled that distance d in 6.996 time. We're getting this by taking our velocity at B and multiplying it by 4/5, which is the component that is in the horizontal direction. But I need to know how much time until I got to point D. Well, that would be the exact same amount of time it takes me to fall from point B straight down to the ground. So my second equation will look at that. When I use my projectile motion equations, I have an initial velocity downward at y. Remember, this is pointing down, that 3/5 is pointing down. And my acceleration will be pushing down, and I'm going to drop 30 feet. So with that, I can solve for my time. What I'll get is that my time will be 0.899 seconds. And if I then plug that into my initial equation, I'll get that the distance is 22.6 feet. So I've said it before, I said it again, you never get rid of kinematics. They're going to keep on coming back over and over again. So thank you for listening. I hope this helps you, and I'll see you all next time. Bye-bye.